Welcome everybody, thanks for coming out. As many of you know, this is our final project. We're a part of Narwhals, so thank you Tom and everybody else. So basically we're gonna present today Neighborhood GPS, Jack, Nat, Rob, and Suleika. And without further ado, we'll just get right into it. So this all kind of started off about a month ago, and thankfully all three of us had no idea what we were gonna do when we started. So one day on the train I was watching a TED Talk, talking something about real estate. One thing led to another, and I thought to myself, it would probably be pretty cool if we could tell people where to live based on, some kind of criteria. So I came in and we threw the idea around, and it kind of snowballed into what we have to present to you today. Some of the big things that we wanted to hit that this project was able to achieve was big data. We were really looking for some kind of project that was had some kind of data analytic aspect to it, because that's really one of the strengths of Python. Also, we were thankful enough to be working, and most of us just living in New York City, which is an awesome city to begin with, but is also pretty huge. And they've gone out on an initiative in the past several years to have a lot of open data. So between the census and the New York City government, they really offered us a lot of data to work with. So with all of those things put together, Neighborhood GPS was born. And what Neighborhood GPS is, in a nutshell, kind of like a sneak peek of it, is basically users come onto the site and they can submit a form, like you see up there, neighborhood qualities, and they can pick all different kinds of attributes that interest them. And we return results. And once these results are returned, you can learn more, you can see maps, you can see them graphed. And we'll run through all that in the demo shortly. But before we do that, I'm going to introduce Suleika to talk a little bit about the architecture.
Thank you, Jack. This is the high-level overview of the project architecture, and I had a lot of fun with working with the fantastic team and phenomenal instructors, and thank you all for the opportunity that I had to participate in this project. And this is just the high level, and it has all the pieces of the puzzle to create this project. It has all the components of a full stack developer, and we had used the Python as the server-side language, and we had used the CSS, materialized CSS, HTML, JS, JavaScript to do the UI front portion of the project, and we used the SQL as our database. So now we'll just start from the beginning. As you see, all those blue, the bubbles, that's the data that we had to collect to start our project. And as you know, the data is the main important part of any project, and we had few challenges we had to overcome. We collected the data from the websites and the APIs, and which Rob and Nate will go through in detail. To process the data to be ready to be loaded into the database, we had used pandas and numpy libraries. They are libraries of some functions which gave us the very powerful calculations that we could do. And pandas has the data structures called data frames, which is single dimension, one dimension to multi-dimension, so which we use to handle large volumes of the data relatively quickly and with minimum code. And we use the Django, that's the software layer, which we use to communicate to the database. And UI side, as I mentioned earlier, we used a lot of fancy stuff, HTML, Bootstrap, Mustache, jQuery, and materialized CSS, which gave us, as you see shortly, very elegant and professional websites, front web pages. And Apache we used, which hosts our server, and also communicates from the front end to the back end, handles the requests, and also validates the security. And DigitalOcean is the virtual server which hosts the websites, and they call it Ocean, and all the websites they call it as a droplets, which is like our project is a droplet in their ocean. So they host our project in their server side. And the search algorithm is the crux of the project, which is written in Python language. which uses the data in the database and the query that is entered in the form by the user to retrieve the neighborhood suited to them and present to them in the form of results, suggestions, as you will see. So that's whole architecture of the project. Nat will go into detail of how the queries and algorithms are done.
I will, but first Rob's going to talk about how we collect the data.
All right, so we collected the data and we got two types of data. We got government census data and API data, and then we'd first collect the census data so we can get the neighborhoods, and we ran this script function that can download hundreds of Excel spreadsheet files. That way we didn't have to manually click them because we'd be here forever. Once we did that, then we used pandas to collect specific things in all these spreadsheets, like neighborhood names, median income, types of buildings, age ranges, and then save those as fields and tables in our database. And then once we had neighborhoods in our DB, we can then use those neighborhoods to make API calls to Google to get the location or a street view. And after we have all collected data from our database, we can then have it ready to be queried by the user. And that brings me to Nat with the algorithm.
Cool, yeah. So actually, one thing on the data collection, a lot of data is not collected at the neighborhood level, or it's hard to assemble at the neighborhood level, and it's really better collected by zip code, or you can basically tabulate, for example, the number of schools in a zip code more easily based on city data. And so another process was to map any data collected by zip code to neighborhoods. So moving on from that, kind of the three parts of the algorithm are, first, connecting user preferences and characteristics to city data. So basically the users put in a mixture of characteristics about themselves, age, income, and gender, and then other things like what is important to them, kind of what type of house would they like to live in, are things like nightlife important to them, and from there we match up which neighborhoods best fit their profile. And what we're looking for are the neighborhoods that basically have the most in common with that user. In addition to that, we both weight the preferences and we try to filter out bad choices. So after we've found the ones that match up best with them, if they stressed that, for example, nightlife was extremely important to them or the quality of schools was extremely important to them, then the neighborhoods that scored more highly on those categories, we would give extra weight to those neighborhoods. And then a final thing we did was give the option of filtering. So for example, you can filter by borough, and then again, going back to the preferences, if they said that the school quality was extremely important, we'd want to filter out schools that are perhaps only mediocre and only get the neighborhoods that have very high school scores. And as a final filter thing, obviously rent range is big and commute time are big. So based on the commute time or the rent or property value ranges that they wanted, we would basically filter out any ones that were too high above their level, their threshold. So with that, we'll do a demo.
All right. So
Sorry, Rob.
let's just step into the site here. Okay. We're up and running. There we go. All right. So this is our homepage. Basically, the beginning of it just gives a little bit of an overview of some of the goals that we've tried to achieve, some of the things that the website does. We give a short explanation on the site in terms of some of the technologies and some of the technical things that we had to overcome to achieve this project. And last but not least, there are 4 short bios about these 4 wonderful people. So please be sure to see that. Besides for that, if you click here on the Get Started, this is our form in terms of collecting the user's preferences. So we can go ahead now and do a live demo if we have any volunteers who'd like to find the neighborhood that they like to live in? No, I have no brave people out here.
I'll
All
volunteer.
right, Cody. So you just yell out the answers. I'll
25 to 34,
all right.
male, 0 children, no,
No.
college and over, single.
And let's just say you make a lot of money, Cody.
I make all of them.
In terms of what kind of home you'd like to live in.
Small building,
Okay.
rent, 1 room, something really expensive.
And
Is there, like, I don't care for the building age?
Leave it blank.
yeah, we could leave it blank. And you drive?
No.
No. All right. And last but not least, tell us about the neighborhood you'd like.
Let's go to Brooklyn.
You can choose multiple, by the way.
Nightlife is not important.
Come on, Cody.
Noise level is less important. Crime level is less important. Public transit will be my commute. I want my commute time to be as small as possible.
All right. 15 minutes good?
Yeah. How does it know where I'm going?
Yeah.
Huh?
It's an estimate to common places in Manhattan.
So to calculate the commute score, we basically took
Brooklyn.
every neighborhood and did an API call on 4 major sites in New York City: Chambers Street, Union Square, Times Square, and 59th Street. And we took all those and averaged them together. So every neighborhood has a commute score based on kind of an arbitrary commute.
The assumption they work
Yeah.
in that area.
Sure to apply to jobs in those locations.
No school. School not important.
None, and not important. All right. Let's see. And here we go. Park Slope, Brooklyn Heights, Dumbo. Notice they're all in Brooklyn. And some of the just some of the features that we added to the site. So first of all, you can keep seeing more results. You can always go back and edit your search to see if something that you've put in will drastically change. Like if we change the boroughs to include more of them, you can see that that's automatically reflected in terms of some of the things that are returned. Also, we added Street View and Map View to where some of these things are. And last but not least, one of the cool features is you can graph all the results you have. So if you see here, these are your 9 neighborhoods that are returned with your query, and they're graphed against your rent, your commute time, the average age, and the median rooms. So if you just hover over one of these, you get to see all those values. Before we end, I think I speak for everyone on my team. We just want to thank all the Byte instructors and faculty for this amazing experience. It's really been wonderful. And thank you.
In particular, Tom.
Yeah.